So to me, I could see that I would translate this. The first thing you always want to do is connect them somehow. So I would translate A to A prime. Okay, and you could do it along vector A prime, or you can use the grid lines, okay, to do this. So if I went from A to A prime, I would add 1, 2, 3, 4, 5 to the x value, and 1, 2 to the y value. So this would be x plus 5, and this would be y plus 2, because we just moved positively on the y-axis 5 places, and positively on the x-axis 5 places, and positively on the y-axis 2 places. So we would go like this. So I would say over here, translate triangle ABC. So you can pick which way. I'm going to start using the grid because it's easier. With x plus 5, y plus 2. You could say write 5 units and up 2 units. Either way will work. This is just better for me. Okay, so you pick which one works better for you. So then they would be connected. Okay, let me, right here, and it would be here. And then we can see that we need to rotate it around A prime D degrees because we're going counterclockwise. And it would actually be 180 degrees because this is a straight line. So we'd move it from here to here. Okay? So rotate triangle ABC around A prime 180 degrees so that AC and A prime C prime line up or coincide. Okay? So then we went from A prime, B prime, C prime, or ABC to A prime, B prime, C prime. We showed that they're similar. Okay? So triangle ABC is similar to triangle A prime, B prime, C prime. And now we're going to do a dilation followed by congruence that proves it backwards. So essentially we're going to take what we did and go backwards. Except for we're going to do the dilation first. So our original dilation was 1/2. So to undo that, we would do the inverse of that, or use the reciprocal. So we would dilate triangle A prime, B prime, C prime from center O with scale factor R equals 2. That's the reciprocal of 1/2. Okay? Then, okay, so let me go back over here. This is going to be really pretty. Okay, so it's going to get bigger and move off. So we have 5 let's do A. 3, 5 would become, A prime would become 6, 10, because we're taking that coordinate of 3, 5 and doubling it. B prime would become 10, 12, 5, 6 times 2. And C prime would become 8, 18. Whew. So then we are moving it from this location to here. So we would translate, this is so hard to do when the grid is not big enough. So if we were at 6, 10 for A prime, which would be right here. Okay, we would want to translate A prime to A. So we would go, I'm going to use the grid and go down the y-axis. So we would go down 1, 2, 3, 4, and right 1, 2, 3, or sorry, left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be y minus 1, 2, 3, 4, because we went down, and this would be x minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because we went left. Okay? So, translate triangle A prime, B prime, C prime with x minus 10, y minus 4, or you could say down 4, left 10. Either way would work there. And then it would be in this location. It would be connected here and not anywhere else on the grid. So then we would have to do the rotation, and the rotation would be the same as it was here. It would still be 180 degrees around, and then instead of being A prime, it would be A. Okay, so rotate triangle A prime, B prime, C prime around A 180 degrees so that A prime, C prime and segment AC coincide. Okay, so triangle A prime, B prime, C prime is similar to triangle ABC. So, is it true that triangle ABC is similar to triangle A prime, B prime, C prime, and that triangle A prime, B prime, C prime is similar to triangle ABC? Yes. So triangle ABC is similar to triangle A prime, B prime, C prime, and triangle A prime, B prime, C prime is similar to triangle ABC. So yes, comma, all that. So this is because when we say figures are similar, that means they are the same shape, just a different size because one has been dilated by a scale factor, period. So, if triangle ABC is similar to triangle A prime, B prime, C prime, then triangle A prime, B prime, C prime is similar to triangle ABC. However, the sequence of congruence would be in a different order. Okay? Or would be different. Okay, our scale factor was different. The way we translated was different. The only thing that was the same is the angle we rotated, but we rotated around a different point. Okay. Exploratory challenge number 2. Whew. Okay. Describe a similarity that proves triangle ABC is similar to triangle A prime, B prime, C prime. So what we're doing is essentially mapping ABC onto A prime, B prime, C prime. So first, you're always going to start off with the dilation. Then you're going to have a translation. Okay, because you'll want to make it the same size. Then you're going to want to connect one of the points, and then depending on how they connect, you can reflect or rotate. Okay, so we're going to dilate triangle this one, ABC, from center O with a scale factor R equals, so to go from 3 to 9 we multiply by 3, to go from 1 to 3 we multiply by 3, so our scale factor would be 3. Okay, so I would multiply this, and this is going to be loads of fun because there's going to be lots of things on this diagram. So we're going to take this -1, 2, we multiply that by 3, becomes -3, 6. C is at -3, 1, so -9, 3. B is at -3, -3, 0, so it would be right here. B is at -3, 1, so it would be here. Okay, and it looks like to me that we could just translate up 1, 2, 3, 4, 5, that would land up. B, 1, 2, 3, 4, 5, they would match. 1, 2, 3, 4, 5. So we could just translate up 5. So translation of triangle ABC with X and Y plus 5, because we went up 5, or you could say up 5, and it's lined up. So triangle ABC is similar to triangle A prime, B prime, C prime. Okay. B says to prove it that ABC is similar to, or A prime, B prime, C prime is similar to A prime prime, B prime prime, C prime prime. So we're going to work a little bit backwards. Okay, so we're still going to do, we always start off with the dilation. So we're going to dilate something. And we're going to dilate triangle A prime, B prime, C prime, because that's what's first. And then we'll translate it to connect them. And then we'll do something else as needed. Okay, so back over here, I'm going to switch colors now. Okay, so if we look at this, our scale factor, so C to B, or C prime to B prime was 3, B prime prime, C prime prime was 2, so 3 to 2, 9 to 6, those are equal, so our scale factor would be 3/2. Okay, 3/2, here we go. 3/2 equals 1.5. Okay, translate triangle ABC from center O with scale factor R equals 3/2. Okay, or 1.5. So let's go try to draw this. Let's see if I can do this in my head. No, probably not going to be able to do this in my head. Alright, so A prime is at -311. Okay. I don't know what's going on here. So, -3 times 1.5 is 4.5. -4.5. Right. Oh, no, I did it backwards. So we're going from here to here. So then, so it should have been 3 or 2/3, 6/9. Sorry, 4.2 over 6.3. So our scale factor would have been the 2/3. I got that backwards. Okay, so 2/3. Alright, so 2/3 of 3 is, or -3 is 2, and 2/3 of 11, 2/3 times 11 is 7 1/3. So 2 and 7 1/3, right there. C, 2/3 of -9, 2/3 times 9 negative is -6, and it's 5, so 2/3 of 5, so it's 6. We're going to go up to 1, 2, 3 1/3, and then B will also be on 6, but it will be 8, 2/3 times 8, which would be 5 1/3. Right here. So then we have this triangle. I would translate, they're all at 1/3, so you're just going to have to pick one. I would pick, you could go to C prime, would be pretty easy. Or C prime prime. So then I would translate from vector C prime to C prime prime. Okay, and we would go 1, 2, 3, 4, 5 to the right. And then we would go up. It wouldn't be 3.5. We would go I don't know what that is doing. Up 1, 2, 3, 4 and 2/3. So x plus 4 and 2/3, or sorry, y plus 4 and 2/3, and x plus 5.
Oh, I found your girlfriend. I also found a football card.
Okay, so translate triangle ABC with x plus 5, y plus 4 and 2/3, or you could say right 5 and up 4 and 2/3. Okay. And then C would be touching, and then you would need to do a rotation, and it would be 90 degrees because it would be here. It would be here. So this is a 90-degree angle to bring A prime to A prime prime. Okay, so we would rotate around C prime. So rotate triangle A prime, B prime, C prime around A prime prime, 90 degrees. Negative 90 because we're going clockwise. So that segment A prime, B prime, and A prime prime, B prime prime coincide. And that proves that triangle A prime, B prime, C prime is similar to triangle A prime prime, B prime prime, C prime prime. Okay, so then we have to verify that triangle ABC is similar to triangle A prime prime, B prime prime, C prime prime by checking corresponding angles and corresponding side lengths, then describing the sequence that would prove similarity between them. Okay, so the angles are congruent, and I'm just going to give those to you. Okay? All of well, I had another color. Alright, so all of the angle A's, if you measured them, would come out to 18 degrees. All of the B's would be 117 degrees. Oh, no, this one. And all of the C's are 45 degrees. Okay? Then we would check that their corresponding sides have a ratio that is equal. So, I'm going to do the two sides that have even numbers. Okay, so first, angle A equals 18 degrees, angle A prime equals 18 degrees, angle A prime prime equals 18 degrees. Angle B equals 117 degrees. Angle B prime equals, am I doing that right? Yeah, 117 degrees. Angle B prime prime equals 117 degrees. Angle C equals 45 degrees. Angle C prime equals 45 degrees. Angle C prime prime equals 45 degrees. And then we're going to look at their ratio. Okay? So, I'm going to look at the sides that have whole numbers. So, then I'm looking at this one and this one. So to go from 3, it would be 3 or 6 over 3, and it would be 2 over 1. Okay, so my scale factor would be R equals 6 over 3 and 2 over 1, which equals 2. So we would dilate triangle ABC from center O with R being 2. Okay, then we would translate, and you can try this on there. I'm just going to give this to you. Translate triangle ABC with X plus 5, Y, so your Y coordinate stays the same, or right 5. Then you would have to rotate triangle ABC around A prime prime (90 degrees). So then, so that side AC and side A prime prime C prime prime coincide, which proves triangle ABC is similar to triangle A prime prime B prime prime C prime prime. Oh, I put 3 of them. And then the last one. So is it true that triangle ABC is similar to triangle A prime B prime C prime, and that triangle A prime B prime C prime is similar to triangle A prime B prime C prime? Then triangle ABC is congruent. Yes, yes, yes. Yes. Triangle ABC is similar to triangle A prime B prime C prime.
Call David.
Yes.
Please send call to Express service. Thank you.
And triangle A prime, B prime, C prime is similar to triangle A prime prime, B prime prime. C prime prime. So triangle ABC is also similar to triangle A prime prime, B prime prime, C prime prime. They are similar because they have the same shape, comma, they just a different scale factor when dilated. So when they are similar to the same triangle, they are similar to each other. Just use a different sequence. That's not what you said. Congruence. Period.